All right. Welcome everybody to this session on building native apps with JavaScript. So what we're going to cover in this session is we're going to talk about Accelerator Titanium, which is a tool that allows you to write in a single code base and build a native application for iOS and Android, and also a couple of other platforms that you probably don't care about. So before we get started, I just want to take a quick survey. How many people have built native Android apps before? Okay. How about native iOS? Objective-C. Is anyone in here using PhoneGap or Cordova? All right, so a few people. All right, so we'll touch on those topics as we go along, and we talk about Titanium. But my own history with this is I started using Titanium about 3.5 years ago to build an app, and this is a screenshot of the old version of our app, my startups app actually called Triplingo. What we do is we build a tool for foreign travelers. So if you're an English speaker and you go to, I don't know, somewhere like Belgium or the Netherlands, or you go to India or Germany or wherever, we have a tool to help you learn the language and do lots and lots of other things within our app. Our entire app is built on Titanium, so you can actually go to the store if you have an Android or iOS phone and download it. So you get an idea of a very complex, visually complex, and also non-visually complex application that has been built with Titanium to give you an idea of some of the stuff you can do. And one of the reasons we use Titanium over something like Cordova or PhoneGap or one of these other hybrid approaches is because we do have a very visually complex app. We have lots and lots of stuff on the screen. We do a lot of stuff in terms of the application being data-driven, so we embed databases. We have lots of features in our app. And so we find Titanium is the sweet spot for us. And so the story behind our company and our application is that we actually came out of a startup weekend, which is a weekend-long hackathon. And I built the first prototype of our application in literally 40 hours that weekend. Okay, I didn't sleep much that weekend, obviously, but we built the first prototype, and it was great for a hackathon because you can put something together really quickly, really nicely with Titanium. So we went back after we finished that startup weekend, and we decided to build a company around it, and had a look at the other options that are available out there. And one of our key business drivers was that we always needed to be on both platforms. We always wanted to be on iOS, always want to be on Android, and at that time, Windows Phone was just getting out of the gate, so we thought that, yeah, maybe one day we might need to support Windows Phone. And again, this was 3.5 years ago. When we initially started, we also had people ask us if we had a BlackBerry version. Okay, how many folks have a BlackBerry in here? Anybody? Not a single person? Wow, okay. So my prediction at the time, so I told our CEO at the time, he was really pushing for BlackBerry because we had a customer that was on BlackBerry, a potential customer, a big customer that was on BlackBerry. And I said, look, just calm down. I know we really want this sale, but I bet you that within a couple of years, they will no longer be on BlackBerry. So if you look around here, you'll see that nobody's on BlackBerry, and indeed, the platform is more or less dead. All right, so let's talk about Titanium. Titanium is open source. Accelerator provides commercial support and tooling and other things like that. It's open sourced under the APL, which is the Apache Public License. So it's a liberal license. It's not a virulent license like the GPL. So you can safely use it without having any concerns for violating the license terms. And what you do is you code everything in JavaScript. And one thing to note right off the bat, I'm going to say this 100 times because eventually someone asks the question at the end. So this is generating code, right? No, this is not generating code. Titanium is not a code generator. It is a JavaScript native bridge. That's the simplest way to describe it. Okay? In terms of platform support, first-class support for iOS and Android. There's a mobile web that's been in perpetual data, so you could take the same Titanium code and it will spit out a mobile web project that obviously you can look at in a web browser. And there's support for Windows 8 Mobile as well, and there's support for BB10 if you're interested in something like that. All right. So again, Titanium is a native bridge. It's a JavaScript native bridge. What you do is you code to the Titanium API on top, and it essentially reaches down into the native layer and does what you tell it to do. The general idea is that you can write once and you can deploy to iOS and Android. And one of the great things about Titanium is that it's not what we call a lowest common denominator platform. They have platform-specific APIs in Titanium. What that means is, for example, if I'm on my Android phone or I'm building against my Android phone, this is a 1+1 device, I can use the Android action bar. Now, is the Android action bar available on iOS? No, of course not. Okay? Similarly, if you're building an app for the iPad, right, I have my iPad here, and I'm specifically building for the iPad, I may want to use a split pane view. That split pane view is not even available on the iPhone, obviously, because it's a much smaller screen, right? So that specific UI widget I can use in Titanium because they support platform-specific APIs. And that allows you to give the user the best possible experience on that platform. That's one of the other reasons we really like it. All right. So I said it's write once and you can deploy to iOS and Android. What we typically do when we work with Titanium is we write once and we adapt the same code base to iOS and Android. So typically, we'll do a feature to completeness on iOS, we'll get it just like we want it, and then we'll start working on adapting it so that it works properly and fits the motif of the Android operating system. All right, that's the way we work, but we'll talk a little bit more about that later. What I want to do right out of the gate in this session is I want to actually start coding some Titanium. All right, and what I'm using here is called, make sure that looks okay. Yeah, what I'm using here is I'm using something called Titanium Studio. This is not part of the Titanium SDK. This is like a side product that they have, but it is a free product. And honestly, you don't have to use Titanium Studio if you don't want to. It's a pretty good IDE. If you look at this, what does this IDE remind you of? It's Eclipse, right? So basically, Titanium Studio is a modified version of Eclipse. Okay, you can't get the Titanium Studio plugins and put them in Eclipse. You have to install their entire thing, but nonetheless, it's Eclipse, right? And you can do lots of different things here. So we can come here and we can say go and run, debug, or package. In this case, I have Android selected, but I could pick iOS, or I could do a mobile web preview or whatever, right? So I can do various different things directly from here. But again, a lot of folks in the Titanium community don't use Titanium Studio. There's a fair number of people who actually just use the command line interface. So there's a nice CLI or command line interface for Titanium. So if you don't want to use this, you don't have to, right? Having those options are great. All right, so I have a little project already set up here. And actually what I'm going to do is I am going to just actually clear everything out. I have this project already launched in the iOS simulator here. Okay, so let me go to my simulator. You can see right here in the left corner, this is the iOS simulator that I'm running over here. And I'm trying to get it to fit that whole screen. Nope, that's not going to work, is it? All right, whatever. We'll leave it at this. And so what I'm going to do is I'm just going to use some of the snippets built into Titanium Studio, and we're going to build a simple user interface. All right. So again, I'm just going to use a snippet so I don't bore you typing all these things out by hand. And I'm going to say create label, and we'll call this hello label. Okay. And you can see what I've done here is I've coded directly against the Titanium API. I'm saying titanium.ui.createLabel. I pass it in properties. What should the label say? The label should say hello Belgium. Actually, let's say hello Devox. How's that? Okay, hello Devox. And we'll make the color on that, let's make it red. I'll set the font size to be something big, say 46. And I'm just going to get rid of the height and width, and for now I'll get rid of the top and left so that it automatically decides where to place it on the screen. Okay, so now when I hit save, you'll see that, of course, I'm going to crash the application because I have a problem here. The one thing I forgot to do is I reached down into the Titanium API on line number 11 here, and I said, go and create me a native label. But I didn't add that label to anything. So in this specific demo application, what I have is I've already opened a window in the background, and I have a container view that I created called titanium.ui.createView. So again, that reaches down into the native layer and creates a native view widget. Okay? But what I didn't do when I crashed the app just a second ago is I didn't add my hello label to a container view. Okay? So nothing happened. Now, if I save this, you'll see it says hello Devox. Okay? So it's a basic widget, and again, this is running in the iPhone simulator over here. And let's change that background to something a little bit a little bit different, okay? Now, one of the great things about Titanium and the fact that it's open source is that there's a huge community of developers around Titanium. Okay, it's not as big as the PhoneGap or Cordova community, but in terms of all the other app dev platforms which are available, such as Xamarin Xamarin and Corona, and those kinds of things, Titanium has the largest developer community. I think primarily because it's open source. But the great thing about having a large community like this is there are tons of smart people in the community who built great tools to help you build mobile applications faster. And that's why we love it. Okay? So here I have my iPad. And I'm using a bit of plumbing called Tizen that allows me to interact with a running simulator like I have here on the screen, or even onto a device like my iPad. So I don't know if you can get this on the camera. All right, if I put this down here, will this be on the camera? And I can stand behind it? Okay. Let's just make sure you can see that. Right, so you can see there I have Hello DevOps. All right, and watch what happens on the screen and on the iPad when I go and change something. Right, you can see it's changed it. Obviously red is no good because I made the text red. So let's change that back to green. Okay. Now as I do this demo, you'll be able to see that as I make changes, because of this tooling that's called Tizen, which I'll explain in a few minutes, what it's actually doing is, as I make changes and I hit save, it takes those changes, actually takes the entire application with my new changes, and it shoots it into the Tizen client that's running both in my simulator and on my iPad. Okay? So what I'm going to do is I'm going to add a couple more widgets here. All right, so I'm going to go to, just going to use the snippet so you don't have to watch me type all this out. I'm going to say, let's create a new button, and let's call this change button. Okay, we need to add it to the parent view. And let's say we get rid of the height and width. We don't need that yet, but we will need to place something. All right, so we'll change the title to change here, and let's just go add it. Oh, and I've done something crazy here. Let's cause it to crash. This is always the danger with doing a live demo, isn't it? You never know what you're going to get. What's that? Ah, yes, thank you. It's been a long week. All right, see if that works. Okay, thank you. All right, I purposely made that mistake just to make sure you were still awake. Okay, just so you know. All right, so thank you anyways. But you can see I just added a change button in here. This is a native button. What I'm doing is titanium.ui.createButton. It reaches down into the native layer in iOS and essentially does new UI button down in the Objective-C iOS Cocoa Touch SDK layer. It takes the parameters I've given it to set up that button. And let's actually change the font size. We'll change the font size later. And once I have that button there, it returns me a reference to that specific button. You can see that reference I have stored in this variable called change button. Okay, so what I can do is let's change this to say change something. Right, and you can see it's still updating on the iPad as well as on my simulator. But once I have that change button, I can do stuff with it. I can add an event listener to say if the change button is clicked, and click obviously is not something you want to use on a mobile device because there's no such thing as a click on a mobile device. What do you want to use? Single tap, right? So let's go shoot that in here. And when I click this, or single tap it, you'll see that I get my pop-up change button was clicked. So I've attached an event listener to a reference to a native widget down in the native layer, okay? But once I have this reference, or a reference to our previous label, for example, we can say hello label dot text equals is it beer time yet, or whatever. Okay, so I'm going to save this, and now when I hit this change something button, you can see that it's changing the text of the label. All right, pretty straightforward. All right, so you can probably put the camera back on me now. That's fine. All right, so and again, as I'm doing this demo, you'll see that the iPad changes. Again, we're doing live code insertion into a running application. Okay, I'll talk more about how that's useful and why we really love it later. So we can do a couple of other things here. So we have this change button, and we do a single tap against it. But because all widgets on iOS and Android are able to capture events to it, we could come down here and we can say hello label.add event listener, and we'll say let's listen for a swipe event now, and we'll say when that swipe event comes in over the hello label, let's set the hello label text to be, I don't know, stop swiping me or something, okay? So I'm going to, I just hit save. You saw there was a little bit of a blink while it reloaded the app, both on the iPad and on the application up here. But now when I swipe this, you'll see that it captured that swipe event, and it attached, I had an event and listener attached to it. We captured that up in the JavaScript layer, and then we said hello label.text, which then sends a message down into the native layer and says, go and change this native label's text, right? We could also change the font size if we wanted to, or we could also change the color, or we could change whatever. So we could do hello label.color equals, I don't know, let's change it to blue or something, okay? So I'm going to hit save. That'll shoot that back down into the native. Let's actually get rid of those yellow lines. And now when I swipe it, it'll change that, and we'll also change the color, okay? So this is pretty straightforward, right, in terms of how we're working with UI widgets. So there are a bunch of different UI widgets. Basically, Titanium will support every UI widget that's available. It also has support for non-UI things like networking, attaching to a SQLite database, et cetera, et cetera. Pretty much anything that the native operating system supports, Titanium supports it out of the box. Right? We'll talk about things that Titanium doesn't support out of the box and how you can extend Titanium to support those more esoteric things. All right? So this is the point where I usually stop and ask questions, but this is such a big room. Are there any pressing questions before we move on? Everything makes sense so far, right? I've tried to keep this very basic up to this point. I can't really see up there. Okay. All right, so we've done this. We've created an application. We're running it on the iPad and within the simulator. So let me take a minute to talk about Tie Shadow. What I have running in the background is I have some plumbing running back here, which is I have a Tie Shadow server running. So whenever a change is made and detected on my file system for any of the source files, what this Tie Shadow process does, so I have a Tie Shadow client running on my simulator, and I have a Tie Shadow client running on the iPad, and then I have a Tie Shadow command line thing running to watch all my files. When it detects a file is changed, it bundles everything up and it sends it up to the actual device. And if we look here, you'll see that, you can see that here's iPad running 802 is connected, and it's going and launching that file that I was working in, which was called firstview.js. Okay, so you can actually see the process that's happening here. And all the Tie Shadow client does is it opens a connection back to the Tie Shadow server and just listens for stuff. So when I make a change and my watch process detects that I've made a change, it bundles up, gives it on one end into the Tie Shadow server, and on the other end I have clients listening to it. They get all that information, and then they render it, or they basically start running the application at that point. Okay, and this is an excellent tool that's provided by the community that lots of people use. Now, one of the reasons we really love it is that developing on iOS is generally not too bad in terms of being able to accommodate for different user interfaces. Sorry, different screen sizes, right? If we talk about the iOS ecosystem currently, there's a myriad of different screen sizes, but Apple does a lot down at the operating system level to help you create widgets, and in terms of layouts and everything, and how they look and how they get spaced and how they get sized. They handle some of that for you, or a lot of it for you actually, okay? But when you talk about Android, it's a whole different ballgame, right? So this OnePlus One device is 1920 by 1080. I think an S5 is like 2588 by, I don't know, like 1800, right? And then you have all the smaller devices and the medium-sized devices, et cetera, et cetera. As you guys are familiar, the Android ecosystem has lots and lots of devices with different resolutions, screen densities, aspect ratios, and all those kinds of things. So when we're building our app on an Android device, what we do is we take the test devices we have, and we have a bunch of them, right? You can imagine if you're building for Android, or for those folks who are building for Android, you probably have a whole bunch of test devices you test on. So what we do is we take these test devices, we install the TiZen client on them, we put them down on the table, all next to each other, and we start coding. Okay, this looks pretty good on a Samsung Galaxy S5, but it looks like it got the view got squeezed out a little bit on a OnePlus One device. Or it looks pretty good on that, but it seems like the pixel density on that HTC M8 is just a little off. So let's go make a little tweak for that, okay? And again, this is all live. So as I type code, I go in, I say, all right, you know what? This absolute positioning is not going to work for this view. So let's switch this to vertical positioning because it just doesn't lay out properly on all these Android devices we have. So let's change that to the vertical positioning. And let's see what that looks like. And boom, you get instant feedback, and you can just at a glance look at all the devices and say, okay, this is what we need to do to fix it. It's a huge time saver in terms of building user interfaces, or even testing things that aren't part of the user interface. Because what do you normally have to do when you build an Android application? You have to go write some Java code. You hit the button that says, build an APK file, and then push it onto a device, right? And that can take some time, obviously. For our application, it takes anywhere, but when I'm building native extensions to Titanium, I generally have to wait somewhere between 20 to 25 seconds for our app to get packaged, APK gets built, signed, et cetera, and then pushed onto the device, right? Whereas what we're doing here with TiZen is instantaneous. It's a huge time saver, and one of the reasons we really love it. And if you look at what's coming around the corner with Swift, Apple have caught on to this fact that the rapid development that you get with something like this, which is not something Apple currently supports with their Cocoa Touch and Objective-C and their entire Xcode toolchain, but they have something in the works which will allow you to do something similar to this. I don't know if you can do it to the device, but you can at least do it to the simulator, okay? All right, so let's move forward. We talked about TiZen, and let's get into a little bit more detail with Titanium. So there are a number of widgets that you can use in Titanium. It basically supports every native widget that's available. So you don't have to worry about things that come out of the box. And in terms of working with events, so again, you have to remember that you're working in JavaScript. So what that means is it's an event-driven type of architecture and platform, or language even, okay? So as you saw in the code that we wrote previously, when we wanted to detect different types of events from the operating system, we added event listeners to it. So one of the things that we do in our application is, in certain parts of it, in a couple of places in our app, we support orientation change. That means you're holding the device in portrait mode, you turn it sideways, and now it's landscape mode. We want to show a slightly different user interface for those specific screens. All right, so what we would do for something like that is we would hook into the main app area, and we would do ti.app.add event listener for, I think the exact one is orientation change. And then when the orientation changes, we can go and apply some code. We can go and apply some code to, whatever. Change UI to reflect new orientation, okay? Whatever it may be, right? So there are events that are against specific widgets, like buttons, labels, whatever. But there are also app-wide events like orientation change, or the app has resumed from being in the background, or other things like that. So when we do Titanium coding, we essentially hook into the API, the Titanium API's exposed events that we can listen for up into our JavaScript layer, and we can do something when those events come in, okay? It's very much like web JavaScript development, but you have to remember that we're not working in a web browser. There's no web browser here whatsoever. These are native widgets we're interacting with, right? In fact, what you can do, and this may only lead to confusion, but I'll show you this quick demo anyways, is let's say for this change button, instead of popping an alert or something, I'm just going to use a snippet here. I want to create a web view. So what I can do is I can say, and let's see what devox.be looks like on a web view. Actually, let's move this. Let's put it at the top 50%. Okay. So what I've done here is I've used the Titanium API to create a low-level web view, and I'm going to attach it to the user interface. It's going to open up devox.be. So let's see what happens when we do this. Okay, it's too far down. Let's move that up a little bit. That's right, I'm using vertical positioning now. So let's make the top at, like, let's say 150. All right, so let's save that. And you'll see that here's the devox.be. Let's move it up a bit more. I don't want to cover that button, but okay. So you can see here's the devox.be website. But what I did is I created a web view widget and told it to open this specific URL. And now I can basically go out and include a website or web page or something like that if I want. Okay, but again, we're coding with native widgets here. This is not like PhoneGap or these other hybrid solutions, which basically bootstrap your entire application and user interface into a web browser. We're working with native widgets. You can include a web browser if you want. Okay, but it's not necessarily something like PhoneGap where you are essentially coding against the web. We're not coding against the web. We're coding against native widgets through JavaScript. Okay? One of the things we actually use a web view for, a web view is very handy actually. One of the things we use a web view for in our application is we have some structured content that shows culture notes for every country, right? Say you're in France or Germany or even Belgium. When the user wants to look at the culture notes, what we have is we have embedded HTML and CSS in our application that's structured content. It's basically a guidebook that what we do is we have somebody else go and come up with all the content. We take that content, we drop it into the application, again, the HTML and CSS, and then we open a web view and point it to that culture content, right, which is an HTML format. So it gives us a tremendous flexibility in terms of how we structure an application and what we can do with it. All right, so we talked about events and some web views. And at this point, most people are like, well, okay, this is pretty interesting. Some people are like, oh, this is pretty interesting. Some people are like, this is effing amazing, right? So the next question at this point is usually, well, how much code reuse do you actually get between the two platforms, between iOS and Android? Okay, so what we see is that 100% of our non-user interface code is portable between the two platforms without changing anything. What's non-user interface code? We log the user in. That's a XHR call, or basically it's a HTTP call to go and authenticate the user. Once the user is logged in, we go and grab their profile information, store it in the application. Okay? And then when they start using our app, we have a bunch of small databases in our app. That's the, for example, the dictionary, word bank, language phrase data. We have stuff for the quiz mode and all this kind of stuff. So all these little databases we use. And I'll talk about databases in a minute, right? So we have routines that we've written that go and query the database and dynamically populate a view and show that specific thing, like whether it's a dictionary, you start typing and it'll go search the dictionary and show you all the words that match that, or if it's our phrase data, when we go and show you the details of the phrases you should learn, or quiz mode. All that is data-driven. And all the stuff underneath the UI is 100% portable between iOS and Android without a single change. That alone is a huge win. Okay, you can think about if you're writing a native iOS or native Android application, what do you need to do to basically you have to rewrite the same business logic twice. You have to write in Objective-C and you have to write in Java. And obviously that can be very tedious and very error-prone. You make a change in the iOS app for the way this specific feature works. Even the non-visual part, or you change the database structure or something, well, guess what? You have to rewrite all that in Java Android all of a sudden. Okay? But you don't have to do any of that with Titanium. So in terms of the user interface code, what we see is that in the newer versions of our app, we're getting approximately 85% code reuse between iOS and Android. That's for UI code. Okay, so we get an aggregate of somewhere in the 90s in terms of just code reuse across the board. But 85% code reuse between iOS and Android. And that 15%, a lot of that 15% is actually little tweaks we had to make to show user interface properly on Android. But there's also other little things. So if you remember at the beginning, I said Titanium supports platform-specific APIs. right? So there is a namespace, titanium.android, et cetera, et cetera. So what we do is we reach into that namespace, and for example, on Android has a hardware back and home button, right? Does iOS have a hardware and back home button? No. Right? They have the one button on the front. That's basically it. But Android has 3 buttons across the bottom. One for home, one for menu, and one for Android, one for going back. So what we do is we hook into the back button so that if the user is using our app on Android, they expect to go back, you hit the back button, right? So similarly, when we build certain views on iOS, we tend to favor using native iOS table view row stylings. And obviously those are only on iOS, so that code is not, it won't even run on Android, it will cause a crash. So we have switches in our code which says, if you're running on Android, do this thing, hook into the back button. If you're on iPhone, don't do anything, there's no back button on that. Or, for building this table view, if we're running on iOS, go use this specific Titanium code, titanium.ios.tableviewRowStylings. And we create the table view row styling so it matches the motif of that specific operating system, right? And then the second part of the switch for Android will do nothing. And sometimes we'll have something in both of them. So a lot of the non-reusable code is actually things that we've done specifically to make the experience better for the user on that specific operating system. Okay? We do not subscribe to the lowest common denominator theory. We want to give the user the richest and most native experience possible on the specific platform they're running on. And we go to great lengths to make sure that happens. And that eventually boils down to writing some code that, again, it's still all JavaScript code, but it specifically uses the Titanium API that hooks into those native things. All right. So again, there's no code generation. We're working with native widgets. Titanium API calls down into the native layer. It is a bridge, not a code generator. All right, so let's look at some Titanium internals for a second. All right, so we'll go over to the right side of this diagram. Let's make this big so that you can see it real good. All right, so your application is on top. That's your JavaScript. Titanium provides the next layer down, which is the UI API, phone API, optional modules. Then you have the bridge layer. And underneath the bridge layer is obviously the operating system, okay? So this is kind of the stack that we're on. This is the abstractions that we built up when we're working in Titanium. So what is this bridge, you say? The bridge, essentially it's proprietary is not exactly the right word. It's a non-standard, it's just an API. What you do is you code to the Titanium API. The bridge is responsible, and the code that you get in that bridge layer is responsible for marshalling and unmarshalling data and communicating calls back and forth from the JavaScript layer down into the native layer. Okay? Again, there's no code generation. So if we look at this, what we did is we wrote something like titanium.ui.createWindow or createLabel or createButton. It goes down into the app platform. The app platform in Titanium is a JavaScript runtime. If you're running on Android, that runtime is a V8 JavaScript engine, right? So very fast. And what the Titanium folks do is they write modules that plug into the bottom of that app platform, i.e. that JavaScript runtime that hooks into the native layer. So they write Objective-C code that allows us to do titanium.ui.createLabel on Objective-C against Cocoa Touch on iOS, and then they go write the same code on Android in Java, Android Java, to go and do, when you call ti.ui.createLabel, down in the native Android layer, it'll do a new com.android.ui.label or whatever and pass it the properties. Okay? So what Titanium does is they embed a JavaScript runtime into your application, and your JavaScript code runs in that runtime. Right? It's not dissimilar from a web browser. A web browser at its very core is just a HTML rendering engine, right? But every modern web browser contains JavaScript runtime, and that JavaScript runtime interfaces with the native layer. In this case, a native layer in a web browser is the HTML renderer and the DOM. Okay? Similar kind of concept, except this is hooking into the native operating system. Okay, so at this point, you're probably like, wow, this is amazing. I'm gonna build an app. I'm gonna go home. I'm gonna build an app today. I'm going to push it onto the store, and I'm going to retire from my job within a week. I'm going to make the next Flappy Bird, right? I'm going to just build something, and I'm going to get rich quick. I mean, unfortunately, we can talk about the economics of the App Store at length. That doesn't happen that much anymore, by the way. But one thing I will caution you on is that you still have to learn the native tool chain. You don't have to become an expert at it, but you do have to spend some time learning it. Right? And the reason for that is what Titanium is, at the end of the day, is an abstraction layer on top of an operating system. Okay? So what other abstraction layer are you guys familiar with? Right? If you're a Java developer, there's definitely one that you've used. That's something like Hibernate or JPA. Hibernate or JPA is an abstraction layer over a relational database server. Relational database, right? So when you're using something like Hibernate or JPA, to be successful at it, what do you have to do? You have to understand relational databases. You have to know how relations are created and how to do queries against tables, because you can do something really stupid like joining two really massive tables and doing outer join against it and blowing your database up and having your boss come over and say, why did you do that? You just brought down the production database. Anyways, you get the idea. You have to know both Hibernate or JPA, and you have to know one layer below it. So the same is true for Titanium. This is where a lot of people struggle, because a lot of folks that I see who start on Titanium, they get in there and they build something really quickly, and then they hit a wall at some point, right? And the wall that they always hit is the fact that they don't know the native operating system well enough to be successful. So using Titanium doesn't mean that you can absolve yourself of knowing the native layer. You still have to know it. In fact, what I do is this week I'm carrying around my OnePlus device. This is the Android phone, obviously, right? When I get back home next week, or at the end of this week, what I'll do is I'll take my SIM card out of this phone and I'll put it into my iPhone 6, and I'll carry that for a couple of weeks, right? Because we build software, apps, for both iOS and for Android. So I want to be a super user, basically, when it comes to just being a user of the device. I want to know all the little things about it because I build stuff for it, right? You would be insane not to know anything about an iOS device and try to build something for it, because you won't understand all the little things you have to do to make a nice user interface or to make some background processes and stuff like that. So my general rule of thumb when people are interested in Titanium and they have no mobile development whatsoever is, well, if you're just building an Android app and you've built a native Android app before, but you want to use Titanium to do it, that's fine. You'll probably be pretty good. But if you've always been an Android developer and you've never built something on iOS, you don't even own an iPhone or an iPad, and you try to build something for it, first of all, you need a Mac to do that, right? So Titanium uses the underlying native tool chain. So to build on iOS, you have to have some kind of Mac. You can rent a Mac in a cloud if you want to get started with it. But my point is that you still need to know the native tool chain. You still need to understand the native operating system to be successful. You don't have to be an Objective-C expert, okay? And they're recording this, otherwise I would give you exactly what I think of Objective-C right now. But it's not my favorite language, let's put it like that, right? And I'm not an expert at it. But I know enough Objective-C so that when I get in some kind of low-level application error that's in the operating system on the device, I can look at that, or I can fire it up in Xcode, have it go to the point where it crashes, and then I can run GDB commands to figure out what exactly went wrong with that specific thing I was trying to do. And in fact, what Titanium does is if we go into our project, let me make sure I'm in the right window here. Yep. So if we go into our project, and I go into, let me make this a little bigger. Okay. So if I cd build, you'll see that I should have a Android and iPhone project in here. Let's go into the iPhone project, and voila, look at this. Here's c2.xcode project. So I can do open c2.xcode project, and I will get a Xcode project. This is essentially my Titanium project with the with the JavaScript bridge and everything inside of it, and you typically don't go in and change any of this stuff, right? But what you can do is I can come up here to the top left corner in Xcode, and I can say, you know what, let's run this against the iPhone 4 simulator. I can also run my project in all these simulators from Titanium, as you saw a second ago. Right, so I could come in here and I'll tab over to it eventually, I guess. Oh, let me zoom out. All right, I can run against all those different simulators. So you see I have all these options in Titanium Studio, and you can do the same from the command line, okay? But what I wanted to point out was what I'll do at a certain point in our project is I'll actually open up my Titanium project in Xcode, and I will run it with instruments turned on. So if you're not familiar with iOS programming, instruments is essentially a way of doing profiling for your application, right, using the tools that they provide you. So I actually open it up in instruments, and I'll go and test a bunch of features in our application and see if I have any obvious performance bottlenecks somewhere, right? And I can only do that if I know and understand the native tools a little bit, right? So I don't want to harp on that too much, but it is important that if you want to be successful, you do need to know a little bit about the native operating system and the native tool chain, because at some point, it will come in handy. Okay, if you're just building like a Flappy Bird, you may be okay, but if you're building like a big application, the more complex your app, the more you probably need an understanding of the native tool chain. All right, so I've already harped about this for several minutes, so I will move on. So the next question, we talked about code reuse. So the next question is, what was the performance like? Because nothing in life comes for free, right? We have this great thing that allows us to write JavaScript to build an app from one code base for two platforms. Where's the trade-off? So there's a little bit of trade-off. If you remember from a few slides ago, what the native layer does, or what the bridge does, is it sends calls back and forth between the JavaScript V8 or the JavaScript runtime. It's not V8 on iOS. They use Nitro on iOS, but you have calls, all your code is running up here in the JavaScript layer, and it calls down into the native layer. So you have a call going down through that bridge and stuff coming back, right? So you're going back and forth between that bridge that you have down into the native layer. So there's a performance penalty to be paid for that. Right? And what we see in our application is we see approximately 90 to 93% of native performance. We've run some tests before. Let's take our dictionary view, let's write the same feature using Objective-C, and let's load it up with 100,000 words. Let's see how long it takes. All right? So we'll load up a table view with 100,000 table view rows in it. We'll do that both in Titanium, and we'll do it also in a native iOS project. And we'll see how fast, what's the difference between these two. So what we see when we run those synthetic tests is, well, those are real tests, but from a synthetic point of view, is we see approximately 90 to 93% of native performance. And we think that's good enough for our application, right? We're not writing like a 3D shooter or a race car game or something like that. We don't need to squeeze every bit of performance out, right? We'd love to have 100% performance, but for us, we're a small company. We have 3 developers, including me. So we don't have time to build native apps for everything. We'd love to be able to build native app, but at the end of the day, it's a business decision, right? How much money can you throw at this specific project that you're trying to build for both iOS and Android? At the end of the day, is it even worth your time and money to be able to have the best possible app, or is it good enough, right? 90% is good enough in my case, right? Your use case may differ, but I find for pretty much everybody building business applications or even utility applications, getting 90-93% of native performance is more than enough to build an excellent, fast, performant, good-looking native app using Titanium. All right, so Titanium has a modular architecture to it. So the core of the architecture is that V8 runtime, that bridge. And what happens is, as Titanium detects that you're using certain parts of its API, titanium.ui, titanium.networking, titanium.facebook, it plugs those modules in at build time so that you get the smallest possible binary. But the key here is that it's a modular architecture, and there are tons and tons of modules already included: networking, user interface. There's a module for database, which we'll talk about in a second. You can get a module for the file system, accelerometer, Facebook, GPS, et cetera, okay? So all that stuff is there out of the box. But there are cases where you will find that Titanium doesn't support something you need. Okay? A great example of that is something like Flurry Analytics. We really like Flurry Analytics, so we're like, okay, let's start using Flurry Analytics in our Titanium app. Well, Accelerator doesn't provide a module for Flurry out of the box. We're like, all right, I guess we're going to have to write a native module. It's actually quite easy to write a native module. You have to write in Objective-C for iOS, and you have to write the native module in Android Java for Android, right? So you do have to write it for both platforms to be able to plug a native library of some kind into your application. So started looking at it. I was like, oh, it looks like we'll have to do this in initialization, and then we'll have to do these specific hooks to start the Flurry library properly, and then we'll have to expose some extra methods into the JavaScript layer to actually send logged events, log time events, etc. And I was like, why am I doing this? Pull up Google, Titanium Flurry module. And within 10 seconds, I'd found somebody had written a very nice Flurry module for Titanium. I went, cloned the repo, dropped the Flurry Titanium module into my project, looked at their documentation, and within 10 minutes I was basically hooking into Flurry and sending analytic data to the Flurry cloud. Okay? Another example of a module that we use, and one that we actually had to write, was within our application, we do ASR and TTS using Nuance. ASR is automated speech recognition. TTS is text-to-speech, right? So one of the features in our app is you can say, can I have a beer, please? And it'll speak back to you in Spanish, uno cerveza, por favor, or whatever, okay? So we have that feature in our application, and there was no Titanium module around it, so we had to build that. And it took about a day to build that module, because you can imagine doing ASR and TTS is fairly complicated, even with the helper library like Nuance. It took about a day to build the iOS Objective-C module, and about 2 hours to build and test the same module for Android. Okay? All right. So let's move on. I'm not going to talk too much about layouts. There is support for various different types of layouts in Titanium. You saw earlier I was using vertical. We could change this from horizontal or vertical to horizontal. Let's go save that. And of course I killed my process that was running back here, didn't I? Okay, it's here somewhere in my buffer. There it is. Just need to start up TiShadow again. Okay, so let's go change this. We changed it to horizontal, and you'll see if I take the top out that these elements will now be next to each other or stacked on top of each other. Right, so what we do is we use a combination of absolute horizontal and vertical positioning, and we have our own kind of border flex layout scheme that automatically sizes things up and sizes things down and does the appropriate layout for different aspect ratio and different resolution devices. Okay, and if you actually go, again, because there's such a huge Titanium community, if you actually go out onto the internet, you'll find people who've written about strategies for doing this in Titanium. Right? We talked about events already. We build some custom controls up in the JavaScript layer, not a lot. So one thing I haven't shown is something that's non-UI. Right? So this is an example of an HTTP client. You can see that in this case we're not really doing anything special. But what you do is you do tie.network.create HTTP client. This does not use a web browser though. Okay? What this is actually using is this is reaching down into the native layer again, and down in the native layer it's creating an HTTP client object in Objective-C and in Java, and it's sending the parameters, and it fires it off. And because this is JavaScript, we don't want this to block, so the way that that module has been written to interface with the native HTTP client is you essentially get an event or a callback. So on load means success, on error means that there's some kind of error. You set the verb, in this case we say get, and then on the last line you say, okay, go and do it. All right? So we make heavy use of databases, embedded databases within our application. So we take all our language data and other stuff, and we pre-populate a SQLite database, and we put it into our app, and that's basically how our app is data-driven. Right? And Titanium has excellent support for SQLite, and I'm not going to walk through all these. You can probably imagine what they do. You can create a table, you can delete it, you can insert into a table. We mostly query from a table, even though we keep some user metrics that we put into a local user metrics database that we can use at some later point in time. But essentially we use it to keep score in terms, we have a little bit of gamification, so we keep score on how much you've learned of that specific language and whatnot. All right. So if you're interested in Facebook, there's a nice Facebook plugin that allows you to allow the user to log into Facebook. It'll interface with the native Facebook app that's installed on the application, for example. And then once the user's logged in and or authenticated with Facebook, you can use Publish Stream and you can spam their Facebook wall if you want. All right. Now, one thing I want to mention is that one of the reasons we really like Titanium is because of the performance, and Titanium has excellent support for animations. And because we're specifically targeting phones, right? Our app runs on an iPad and Android tablets, but we specifically are targeting phones. And a phone is a small screen, obviously, right? So, I mean, the screen on this phone is huge. If you go look, one of my developers still has an iPhone 4S, and I look at that, I'm like, holy crap, that is so small. How did you ever use this, right? Or how did I ever use it? I used to have an iPhone 4S. But anyways, the point is the screen is small. So what we do is we use lots of animation in our application to give the user visual cues so they understand how to use our app without having a tutorial or anything like that. Okay, so we use visual cues in our applications, which are in the form of animations and other things, but mostly animations. So one of the things, for example, we do is when you're browsing a phrase, you can touch a context button, and this little bubble pops open like this. And then you touch the bubble or the button again, and it goes away back into it. So we make the app visually beautiful, and also we use the animations to give the user visual clues as to how they should be using our application, so that it's just intuitive. All right. So unfortunately, we didn't get a lot of time to talk about titanium alloy. I know that was in the description, but I do want to spend the last few minutes talking about that with you. So let's go into our code base here. And what I'm going to do is I'm going to open up an alloy application. And what titanium alloy is it is a model view controller framework built on top of core titanium. Okay, so what I've been showing you so far in the code that we have here, this is essentially what's known as Titanium Classic. Okay, but the folks over at Accelerator have been working on this for a while, or working on Titanium Alloy for a while, and what it essentially does is, if you look at the screen, you'll see that I have my app folder here, okay, and here's my controllers, here's my models, and here's my views. Let's open up one of these views real quick. Okay, so if we go open this view up, you'll see that it has, this is not HTML obviously, this is XML, but you can see here's a table view row, that table view row contains a view, that view contains two labels. You see what this is. This is essentially declarative markup for defining what a view should look like. And then similarly, if we go into our controllers folder, we'll have a controller for various different things, filtering, whatever. This is essentially just straight JavaScript code now, but this is essentially the controller that binds and controls the view in certain ways. And for styles, what they've done is they've created this thing called a TSS file. And the TSS file, not exactly CSS, right? Because CSS is its own little funny language or whatever. But the TSS file is CSS-like, but it's actually just a big JSON file. Right, so you can see that this is properly structured JSON, and what you can do is kind of like CSS. You can say for anything that's a label type, it should have this default color for this specific widget. And we're looking at fugitive row right now. And then for things that are of this class called vgroup, it has this. Things that have this specific ID will have this styling applied to it, et cetera, et cetera. Okay, and if we go look at the models. One of the things that is neat about Alloy is that it actually uses Backbone for the model infrastructure. So if you go look at the includes that Titanium Alloy has as kind of like helper libraries, one of them is Backbone. So they use Backbone models as the models in the MVC. Right? So there are quite a few JavaScript utilities and libraries that you can actually use in Titanium as long as there's not hard references to the window object. Okay? So what these guys did is they took Backbone and without changing much, they just dropped it in and started building this Titanium Alloy framework around it. But anyways, I wanted to give you at least a quick flyby of what this looks like, so you get an idea. You have options, right? What I would suggest you do is, if you're new to Titanium, what you should do is you should probably just write a small project with Titanium Classic, because at some point you do need to write just straight Titanium Classic. If I go back to this fugitive.js, or let's pull up index.js, right? You can see that this is basically just, standard Titanium style code. Right? You can see I'm creating a map here and an annotation, and then doing a couple of other things. So you still kind of need to know Titanium Classic, and you need to know it reasonably well. All right? All right, and with that, I think we are at the end. Oh, we are. Okay. So thank you for coming. If you have any questions, happy to stick around to answer some, or if you want to go get beer, we can just go get beer. All right? All right, so thank you for coming. I hope you enjoyed the session.